Hello, and welcome to today's special webinar event. We're here to talk about how modern data protection can empower your team. Today's webinar is sponsored by Rubrik and produced by Actual Tech Media. My name is Scott Becker. I'm from Actual Tech Media, and I'm excited to be your moderator for this special event. Now, before we get to today's great content, there are a few things that you should know about this webinar. First off, we want this to be a very educational event for you, so we encourage any and all questions in the questions box in our webinar control panel. Not only will we have team members responding to questions during the live event, but we'll also have a dedicated Q&A session at the end of the presentation where we'll discuss in greater detail some of the top questions. Second, in the handout section of your webinar control panel, you'll find that we're offering several resources. At the top, there's a Get Started with Rubrik link. We've also got links to the Gorilla Guide Book Club, as well as a link to the ATM Event Center, where you can find more great events like this one. So I encourage you to check out those handouts now, or those links rather, and consider sharing them with your friends and colleagues. Third, at the end of this webinar event, we will be awarding a $300 Amazon gift card to one lucky attendee on the live event. If you're watching this webinar on demand, I'm sorry the drawing has already occurred. If you're the winner, you can choose to donate the value of that gift card to one of our selected charities. Thanks to generous prize winners on previous Actual Tech Media events, thousands of dollars have been donated to charity, so thank you in advance if you make that choice today. Official terms and conditions of today's prize drawing can be found at the bottom of the handout section or at actualtechmedia.com. Just scroll to the bottom, you'll find the prize terms and conditions link there. And finally, one of the best benefits of this event is the opportunity to ask a question of our expert presenters. So to help encourage your questions, we do have a special additional prize for you. That's another Amazon gift card, this one for $50 for the best question. At the end of the event, we'll look at all the questions, pick out the very best one, and contact that prize winner. And with that, let's get to today's fantastic content. It's my pleasure to introduce you to our presenter today, Frank Schwach. He's Senior Solutions Architect at Rubrik, and later Steve will be joining to help out with the Q&A. But I am going to turn things over to Frank.
Thanks very much, and thanks for having me. Greetings from sunny Germany. In today's session, where we talk about how modern data protection can empower your team, we are going to talk first about the daily tasks that a DBA has. So what are the daily operations that a DBA has to run through? Then a real-life challenge about a simulated failure of a database and how to recover this using older or legacy approaches compared to how modern recovery operations can help you winning some time. Then we talk about modern data protection requirements. Like Recovery Manager in Oracle in the past days was the only way how to back up a database, and it's still today, but how or which features have been added to the Recovery Manager to make it easier, and the same for Microsoft SQL, for example. Then we talk about modern recovery operations. Yeah, can you actually make a database accessible without the need to restore it? And how do you make the data available when you actually need it? So how can you ensure that you can restore and recover to any point in time, given the time frame that you have agreed on? Then hopefully we will have time for a short demo, and we're going to open up for Q&A in the end. Now, the daily tasks of a DBA are usually keeping the applications up and running, fine-tuning statements, creating or installing patches, validating the systems, doing compliance auditing, provisioning test and dev environments, but also backup and recovery, ad hoc recoveries, disaster recovery testing, and also validating the backups. So, and what we try with modernizing the way of backup and recovery of a database, we try to eliminate the time you need to spend on all these backup and recovery tasks so that you have more time for, patching, keeping the system running at peak performance, and so on. Now, a challenge, just imagine what if you have lost a schema in a production database. Normally, you would restore and recover the entire database. This will cause downtime, and so on, and it's quite a lengthy process, and it takes as long as the data takes to be restored over the network from a specific backup target. Now, in this example here, we have the situation that engineering has finished a final sprint. Management is really thrilled. They've never seen before such a functionality, visibility, and agility. And then suddenly, shortly before the presentation, about 2 years of data has simply disappeared. Nobody can pinpoint when exactly that happens. Was it yesterday or the day before yesterday? But leadership wants you to recover it with zero downtime on that production system. Now, the plan is to restore the database to a different host and then just extract the data that has been lost on your production site. And then you import that back into production while it is up and running. But you're working with a 200 terabyte database. So in this example, if we go with the legacy execution, what would you do? You would identify a server that can host a 200 terabyte database. You would then, if it is Oracle, create an Armin script and modify it according to the target machine's configuration or environment. Then you double check if the hardware is sufficient to host that database, and then you start the recovery. 200 terabyte over the network can take a few hours. Then you check the data on that restored or cloned database from the backup, and you found out that that was the wrong point in time. So you delete that just restored database, and you go to the backup administrators and request the next backup. Yeah? And it's again the wrong point in time, so wash, rinse, and repeat. And then once the database has been restored to the correct point in time, you export that data set, and you can then copy it over to your production machine and import it there. With the modern approach of making databases accessible, you will find an alternative host. You don't need to provision any disk space on that server. You select the point in time yourself from which you want to have the backup available. Then you simply mount the backup without restoring it. So the database, the 200 terabytes, will not traverse the network. And you find out, oh, that was the wrong point in time. So you simply dismount it with a matter of seconds, and you mount it again. And then you see it's the correct point in time. You then extract the data and you import that set back into production. So with the legacy approach here, you have tons of manual steps: preparation, creating the scripts, running the job. You have interdependencies between the teams, so the backup administrators and the DBAs. You need to have a lot of space available, and it takes probably a few days to complete that task. With modern data protection, the DBAs will have kind of a self-service way of creating clones on a different machine, and you don't need to talk to the storage administrators who need to provision you some disk space for that. This is all not required. And since the data is not going over the network, it's being done in a few hours instead of days. And this is what we are focusing on today. Now, modern data protection, how does a modern solution look like? Ideally, a modern data protection operation for applications and databases is completely SLA driven. So you set up your service level agreements where you specify this database follows the gold, silver, or bronze kind of importance, and the gold ones will be backed up every 4 hours on the database side. The transaction logs or archive logs will be backed up every 15 minutes, for example. If it's silver, then these requirements or this pattern is a bit loosened, so you may back up the database twice a day and the logs every 1 hour. And for bronze, where you apply databases with low importance, you may back up once per day and back up the logs every few hours. So this is a set of, or this SLA needs to be applied then to your database applications according to their importance. And what that SLA also does is it will archive the data maybe into the private or public cloud S3 storage or NFS shares or even tape, and keep it there for longer term for legal requirements. With that, it should be simple to set up, use, and scale. It should support all the enterprise applications out there. Data recoveries and data virtualization needs to be supported so that you can make the databases or data accessible or available without the need to restore it. It should be built for the cloud, so you can archive the data to cheap cloud storage. And it should also provide you kind of a Google-like search on the cloud to find the correct objects. Database name is clear, but if you would browse for files or objects, then this Google-like search is important. More important today is, in times of ransomware, end-to-end encryption, native immutability against ransomware. Keep in mind, legacy backup solutions have backed up to disk or tape, and that was always available. The tape has been taken out of the tape library, put into a safe, and was air-gapped and therefore non-changeable afterwards, so nobody could manipulate the data on a tape. But today, you're backing up to disks or SSDs only, and that's always vulnerable. Therefore, you need to have a mechanism to make the data physically immutable against any kind of ransomware attacks or accidental deletion by, for example, the backup administrators. And ideally, that solution should also have kind of AI or ML-driven ransomware detection that could throw an alert if there are any anomalies detected on your backup data. So with a modern data management tool, everything should be automatically discovered. So all databases and applications that you want to protect should be discovered automatically. And that without scanning your entire network, right? So what an application needs to do is it should, for example, check for all running databases on one specific host. And then if you apply this SLA on host level, it will apply to all databases on that host automatically. And that also includes newly created databases. With legacy solutions, if a DBA creates a database on an existing server, once that database is up and running, they need to speak to the backup administrators and say, hey, there's a new database, please include that in the next backup. With automated discovery that's happening frequently, the database will be automatically protected when the next job kicks in. Yeah. Replication and archival are important mechanisms, A, for long-term storage, and secondly, for disaster recovery situations to, recover from complete site failures because you have the data replicated to a different data center for shorter term retention. And last but not least, self-service clones are one of the tools that the DBAs can use to create themselves the clones that they need without talking to the backup administrators and without talking to the storage administrators. Now, what a lot of people say, or when I speak to database administrators or CIOs, the question always comes up, hey, what about deduplication? And now I ask you all to give this some thoughts because this is more like a philosophical question here. Deduplication is a nice tool to have, but if you don't have to deduplicate, the better it is because you would save a lot of CPU cycles and a lot of post-processing and so on. So if we look at that table here, traditional operations, if you back up a database in the normal way, you would have like a little CPU load on the server. You would have quite high I/O on the source disks from where you're backing up from. You would have quite high I/O on the network or data traffic on the network. You would have some post-processing load because the data on your backup target needs to be compressed or deduplicated or whatever. And the backup storage consumption in the end for the backup is also quite big. Now, in the second line, you see the traditional operation with compression enabled. A lot of DBAs say, hey, I would like to take compressed data backups because it's going faster over the network. Yes, that's true, but it's also creating kind of a heavy load on your database server. The I/O on the disk is the same. I/O on the network will be a little bit reduced. You don't have to compress on your backup device anymore, and backup storage consumption is like 50%. Now, to be more efficient in storing the data on your backup device, de-duplication has been invented. De-duplication is putting a massive load onto your application server. The I/O on the disks is also quite high. I/O on the network is very little because it will only transfer the changes because the database server decides what data needs to be sent. And the backup storage consumption is very little. With the modern approach of running incremental forever backups, there is no need to deduplicate the data. With tools like block change tracking or change block tracking, the other way around, the application decides automatically which blocks of the database need to be transferred. And since they are new blocks since the last backup, it's very, very unlikely that there will be a duplicate included that can be eliminated on the backup target. So the CPU on the source is really low. So it reads a block change tracking file, addresses directly the block that needs to be backed up, and sends it over. There is no need to scan the entire database for that. The I/O on network is as low as if it would be with source-side deduplication. There is no post-processing, and the backup storage consumption is really low. So if you compare the last two lines here, which have the same result on your backup device, which one would you prefer? The one that's creating high load on the CPU and on your disks, or the one that can go natively? And that is really what drives today's backups. It is trying to back up only what the backup target doesn't have already. And that can only be done through incremental backups and with less CPU and calculation sizes for deduplication hashing and so on. And Oracle, for example, has now implemented the suggested backup strategy, which is based on incremental merge image copy backups. In the past, Oracle created backup sets. So it took a few data files, a few archive logs, control files, and so on, and put them into one package, sent that package over to the backup device, and it was stored over there according to their configured retention. And that happened like on a weekly full backup basis and daily incremental backup basis, and the data to make that accessible had to be restored. Now, a lot of customers are using Oracle's fast or flash recovery area, where they have a copy of their production database located, and that will be updated according to this drawing. So the first backup or the first copy to the FRA is an exact one-to-one copy of your production data files, control files, and so on. And then every subsequent backup will be a level 1 backup set backup that will be restored or merged into the previous full, creating you a new full image copy. So, and this happens in an incremental forever fashion then every few hours, because it allows you to create very frequent database backups because it's only transferring the small incrementals and not the real full again. The problem with this is if you don't have the right storage, you can only restore to your last backup, so you won't have any point-in-time recovery capabilities. In order to offer point-in-time recoveries, you need to have a solution, a storage, where your image copy resides on that can be snapped, where you can freeze the status of every new full image copy. For Microsoft SQL, for example, usually when you use SQL Management Studio and you back up the database, it will create BAK files. So it will put your MDFs and LDFs into BAK files, similar to an Oracle backup set, and data from there can be restored. Now, with the Microsoft SQL VSS writer and the correct file level filter drivers, you can address the changed blocks immediately and only transfer what has been changed. So VSS snapshots allow you to take incremental forever backups. And you also have to run your transaction log backups in order to provide point-in-time recoveries if the recovery model of your SQL database is creating transaction logs. So, but you may get my story here. The goal is really only transfer what you really have to transfer. So what has changed since the last backup? That is the important message here. Now, Incremental Forever has got a kind of a bitter aftertaste, because if you run a full backup on day 1 and on day 200 you want to restore something, who guarantees you that your backup from day 1 has no corrupt block on the backup side of things? So you need to validate those backups quite regularly. It doesn't hurt, but you need to check if the data is 100% intact, because you only have one baseline. And this, a modern data protection solution, should automate that process for you. You should be able to specify any point in time and then say, hey, validate, is this database restorable and recoverable? And if so, give me a report or send me an email that the last validation check was successful. On the SQL side, you can use the DBCC check commands on a live-mounted SQL database, or you can use Oracle's restore validate command, which will simulate a restore where it reads every block, but it doesn't send it to your production server. It will just read it into memory and discard it. Now, the operations or an ideal backup solution should have role-based access control, but also role-based operation control. If you have, for example, a DBA group that is allowed to manage SLAs and add databases into the backup, then that's okay. DBA group 2 can maybe create clones to a different server, and DBA group 3 has full access to also overwrite the production database and restore in place if needed in case of a disaster. But they should only be allowed to do that if, for example, the DBA managers have authorized that operation. The authentication should be done ideally via username or password, or an API token, or a time-based one-time password with two-factor authentication. So let's talk about the recovery operations. I mean, that's why you actually do your backups, right? And only Oracle is the company that named their product correctly, because they called it the recovery manager and not the backup manager. So what Rubrik did Rubrik is a relatively new company on the backup and recovery market. It exists since 6 years. 5 years ago, it released the first product and could only do VMware backups. But a lot of customers came back to Rubrik and said, hey, what are we going to do with my databases? Oracle, SQL, SAP HANA, and so on. And then we said, okay, let's look at what are the challenges. And the challenge that is always there is data growth. So how do you recover a multi-terabyte database within minutes? We brought up a solution for that called instant recovery. The next question is, in times of IoT today, where you have thousands of databases but really small, so like 100 SQL instances running 4,000 databases, how do you manage these thousands of databases from a backup and recovery operation? You can only do this using an SLA policy. And last but not least, how can you give the DBAs or developers or QA an option to create themselves clones without interfering with the backup and so on, without provisioning storage and so on. So this is really what the 3 goals were, and that comes in kind of a one-click delivery or via API calls. Now let's talk about recovery options. If you restore back to the original host and you copy the files, that's a simple restore. If you copy the files to a different host for test dev or for running a report or something like that, that's being called clone. If you present the files from the backup storage directly without restoring it, so presenting via secure SMB on Windows or NFS on Unix or Linux, then back to the original host, that's called instant recovery, and to an alternative host, that's called live mount. What Rubrik gives you in addition to that is the DBA managed recovery, where Rubrik just presents you the backup data and lets then the DBA do whatever they want to do with that backup data. Run an Armin script against that backup data, or whatever is possible. Now the use cases here are really breaking. The live mount functionality, where you back up to your backup device and you present multiple point-in-time copies to different server of one and the same database, is making life much easier. Yeah. Again, there's no storage provisioning required because that Rubrik appliance will serve as database storage for kind of a short-term clone if you quickly want to test something or restore just a table, as we've seen in the example earlier. Then recover production, there is no magic in here. Yeah, you back up to here and you restore back to your original host. That's like a legacy operation, but still a requirement. Instant recovery, however, makes it much faster to bring the database back. So see instant recovery as a live mount back to your original host. So you can restore your production database without the need to restore it. And if this is Oracle, for example, and you have the Enterprise Edition and version 12 or higher, you can actually restore the database while the database is open and running from your backup storage. Yeah. This is a simple alter system move data file command, where you restore while the database is open and productive. And their performance, for example, doesn't really matter because your phone will be silent. Yeah, there are no calls coming in, hey, the database is down. No, it is up and running, maybe at slightly degraded performance because you're running over the network that has got latencies and so on, and it's coming off your backup storage, but the system is up and running and online. Yeah, so downtime has been minimized, and you do the restore while the system is up and running. And clones are really being done for long term. So you back up to your Rubrik cluster, and from there you restore to a different server where you also have the storage provisioned, and that's being used for kind of long-term clones that you want to work on and also maybe back up in the future. I said automation is key, and Rubrik is built on an API-first strategy. So everything you can see in the Rubrik UI as a button that you can click on is first being implemented as a RESTful API endpoint. And then the UI developers decide if that endpoint makes it as a button or as an option into the UI. What we don't want to do is overload the UI with functionalities that's maybe only required by 2% of the customers. Yeah. So, and the API is allowing you to automate all things with tooling integrations like Ansible, Terraform, VMware, vRealize. And what we also offer are SDKs for various languages like Google Go, PowerShell, and Python. And the Python SDK is my personal favorite one. It makes it so easy and it allows you so fast to create a clone of a database that's unbelievable. So there is no need to log onto the UI to do certain operations. And if you are using ServiceNow or any other tools, this can be included as well. So it can open a ticket on a backup failure it can respond back and run an operation on the Rubrik side by calling the correct RESTful API endpoint. The development or the automation itself is pretty simple. You can use Google Chrome's Network Monitor or Rubrik's API code capture to find the correct API endpoint. In this example here, on the right-hand side on the top, you see that we are mounting a Microsoft SQL database with a specific identifier. And in the payload section at the bottom, you see that what should be the name of that live-mounted database, so you can rename the DB, from what timestamp, and to which target Microsoft SQL instance should it be mounted. And that's all you need. You can put this into a curl command to call that API directly or use the SDKs that I talked about earlier. What we also have is a RESTful API playground where you can test all your automation functionalities. If you, for example, here is the live mount again for Microsoft SQL. You put in the identifier, you configure the payload in the bottom field. As soon as you click the button execute at the button, it will create the live mount, and it will also give you the curl command to run this operation from command line or from any kind of tool. What's also available is a documentation. In this case, you say if you want to live mount an Oracle database, what are the required parameters? And on the right-hand side, you see some examples about how you can provide these variables or values that are needed for certain operations. You can orchestrate your you can orchestrate the automation if you want by using Puppet, Chef, Ansible, or SaltStack. The automation tools also include Rails and not just Python, PowerShell, and Go. And as I said earlier, IT service management with ServiceNow, vRealize, or vCloud Director can be included as well. Yeah, we are part of the Open API initiative, and everything that we have as use cases is available on GitHub. And we also have a end user community called build.rubrik.com, where end users can actually upload their use cases, their automation orchestration use cases, and share that with other Rubrik customers so they don't have to reinvent the wheel. So let's recap. Modern database protection and recovery, the must-have requirements are automation and orchestration through a set of SLAs and also through an API. Yeah. I think personally, DBAs who love the command line should not be forced to use a UI for their daily operations. And that can only be done through a full-blown RESTful API. Then the daily backup operations that are happening according to your SLAs or legal requirements should only cause a minimum of I/O and CPU load on your database servers while the backup is running. You need to have flexible and storage-efficient creation of clones, like live mount operations. A highly secure and immutable backup storage device is key. Just as a side note, Rubrik is based on an append-only file system, which works similar to the blockchain technology. So every block written to the backup storage itself is a transaction that cannot be undone or reversed. Yeah? And with that, it makes it impossible for any kind of ransomware attack or accidental deletion to manipulate any kind of data. Backup and recovery validation should be automated in times of incremental forever backup strategies, so you can always be sure that your data is within the recoverable range according to your configured SLAs. If you have ransomware and anomaly detection, this is a big plus. Yeah? So my database backup has grown yesterday by 10%. Usually it grows 10% per month. What has happened? What kind of anomaly has triggered the alarm that I have now received? Let's investigate that. Replication for disaster recovery purposes. I don't know if you've seen that burning data center in France recently. That is a key requirement. Replicate the data into a different data center and keep it in that different data center for short term, just in case. Don't keep it there for long term. For long term, you would use an archival storage, which is cost efficient, like, again, S3 buckets in the cloud or NFS shares somewhere else, or even tape. SLA compliance reporting is a must. If there is an audit happening where you have to prove that your backups are available, and if that's based on SLAs that you may have with your customers, then you have to prove that this data is available for recoveries. And last but not least, your data protection and recovery solution, you have to have the trust and the confidence in it. It doesn't let you sleep good at night if backups are constantly failing for what reason ever. You're opening support cases over and over again. So trust and confidence is one of the most important requirements of a modern data protection and recovery solution. So before, I think we have like 10 minutes left before we open it up for Q&A. Let me quickly show you what I just prepared before we started this session. So I'm going to share my screen now. On that screen here, you have the Rubrik UI. Actually, one thing I don't want to show, but again, everything in here is a RESTful API endpoint that you can call. And I will log on to this system. And what I did here is look at this Oracle database. It's called DMO-CDB. This database has been live mounted just before this session started. So I created a live mount of this database. And you also see down here like the backup history of that particular production DB. And you see that the logical size of this test database is 631 gigabytes. I consider this medium-sized. The largest one I've seen so far is now at 280 terabytes, a single Oracle database. With the last database backup, it only transferred 9.12 gigabytes. Incremental Forever makes this possible. It created a new full image out of that by recovering these changes directly back into the existing image that resides on this Rubrik cluster. What I then did is I selected a point in time. I took the slider here, selected a point in time from where I wanted to have the database back. Click here on Mount and selected the target machine where I want to mount this database. And this database, so by clicking Mount, it will start that operation. I did that. I have one live mount available. The reason why I have prepared that, just to show you, this live mount took 7 minutes and 22 seconds, which is quite a big amount of time if you only have 60 minutes for your session. So that's why I created this up front. So it took 7 minutes, 22 seconds to create an exact one-to-one copy of your production database from the backup to a different server. And I'm logged on here to both servers. So this is my production machine, which is called DMO01. The database is called DMO-CDB, and the DB ID ends with 462. You see that all the table spaces, and also this is a pluggable database over here, you see that this is stored on an ASM storage. Now, the live mount of this database is on Demo02, the second machine, same name, exactly the same DB ID, which ends with 462, but the data is on a native file system. And that native file system is a snapshot on the Rubrik site. And I can show you that by simply running a df command. So we present 4 NFS shares with the full-blown Rubrik cluster capacity to play with this live-mounted clone. We deliver all the scripts that are required to instantiate the database on that server and to start up an instance, restore the SP file control file, make the necessary changes like memory or ASM disk group naming and so on. And then we simply switch the data files to copies and say, hey, don't look in your ASM disk group, use the data that's being presented by this snapshot. The only thing that is local in this clone are the temporary table spaces and the control file and the SP file. But that's like a tiny amount of the total storage here. So this is 630 something gigabytes, sorry. So that's one operation. And if I say, okay, I now finish testing, I can just go into the live mount section here and say, dismount this. I finished my work. I extracted the table that I've lost in production. I imported it back into production. Everything is good. So let's unmount this. And this database, if we go here in the Oracle DBs, this database you see is assigned to an SLA called Oracle Demo. And this SLA is defined to run database backups once per day, keep it for 14 days. The weekly backup on a Sunday should be kept for 6 weeks, and the last backup of the month should be kept for 1 year. So this is the typical grandfather, father, son principle of retention management. We don't have replication configured here, otherwise it would be listed, and there is also no archiving configured. And you see the storage consumption on the Rubrik side according to this database. And you see, 30 days ago, we are still only storing 153 terabytes. So this 600 gigabyte database, which is under heavy load, has been compressed and then incrementally updated over the time. Now you can create or edit an SLA very easy. You create an SLA per requirement of your business SLAs. So you could say take every 1 hour a snapshot, every 4 hours, and keep it for a certain number of days. You can also be more granular in the long-term retention, like monthly backups should be kept or yearly backups should be kept for a certain amount of days. The archival is just a toggle button over here. You select your archival destination, move the slider and say, okay, I have a total retention of 360 days, but I only want to keep 37 days on this cluster. The rest will only be stored for legal requirements. You can also instantly archive the data. So everything that has been backed up to Rubrik will immediately be sent to the archives. And you can enable the replication where you specify a different cluster and you say, okay, replicate, but keep only the replicated data for 9 days on that DR site. So that's how simple it is to configure an SLA. And then you can apply that SLA on host level. You see here, it's applied to this one server. So it is automatically applied to these 2 databases that are running on that server. If I create a new database here on that machine, it will be automatically discovered, and it will automatically be assigned to that SLA. So I will stop the screen share now and go back to my last slide. And with that, I say thank you very much, and I hand it back over to Stephen.
Well, thank you very much, Frank. At this point, we're going to go into questions from our viewers today. First question, does Rubrik support Oracle RAC and Exadata systems?
Yeah, that's by the way a very good question. Yes, we do support real application clusters. A real application cluster is simply an Oracle server that is running one central database via multiple instances on these different cluster nodes. But one anecdote, we are also officially supported to run on Oracle Exadata boxes. This is Oracle's engineered system where Oracle usually does not allow to install any kind of third-party software. Since one of the co-founders of Rubrik has been working at Oracle previously and he there invented the Exadata, that opened us the door because of his contact that he still has to also install our software on that box because we're not doing any harm on that system.
Understood. Thanks for clarifying. Okay, next question. Can you give a simple example for using the RESTful API with Oracle?
Yeah, I mean every option you have to back up from the UI can be done via a RESTful API. And for example, if you have set your SLA to run Oracle archive log backups every 1 hour, but sometimes it happens that you have high load operations where a peak of archive logs are being generated. What you could do is you can take that API endpoint call to run a log backup and include that into kind of a watchdog process that's monitoring your archive log destination. So if you then say, hey, if my archive log destination is filled up by 80%, run a log backup and delete the logs that have been backed up in between that 1 hour interval that is statically configured. That's just one example.
Understood. Thanks, Frank. Okay, next question. You said the data is immutable inside the Rubrik environment. Can you tell me more about this?
Yeah, I briefly talked about this. So the underlying file system of the Rubrik clusters, which is a zero trust cluster with erasure coding to distribute the data, that file system, we call that scale data file system or Atlas. That file system is working in an append-only way. So again, similar to the blockchain technology that everybody hears about in the news today, every transaction or every backup is a transaction into the append-only file system and cannot be undone. The only thing that can happen to that data is that it exceeds the retention configuration and then expires naturally. Yeah? But data cannot be deleted ad hoc. And for legal requirements, we can also put data on legal hold, so they can't be deleted. And we also can configure a retention lock feature, which does not even allow the administrators with time-based one-time passwords to age any data before the configured SLA retention.
Understood. Next question, what are DBAs most impressed or surprised about when they see Rubrik?
I would say the simplicity. When we run proof of concepts, for example, you haven't seen me, and I mean, you have to believe me, I haven't prepared anything for that live mount that I have just shown. Yeah, I haven't touched a single RMAN script. I could have done, but if you want to customize things, we still let you, creating own RMAN scripts with very, very, very advanced operations. But normally, for, I would say, 90% of the operations in an Oracle or SQL or SAP HANA environment, you don't need to touch any kind of scripts. And everything is fully automated. Even adding servers to the Rubrik ecosystem can be fully automated. And that makes it simple. We guarantee, for example, running a complete VM estate or VMware estate after 15 minutes when we mounted the bricks into the rack. So the system is up and running quickly. It auto discovers what's there, and it will then start the protection of your data.
Understood. Thanks, Frank. Next question, you mentioned you can protect SAP, Oracle, and other databases. Are separate licenses required for each?
No. Actually, you purchase the back-end storage of the Rubrik cluster. So let's say a 200 terabyte version, or if you need more, you can just add another Rubrik cluster that replicates and distributes itself automatically. And you just pay for the back-end storage. Yeah? And what we also say is, for long-term storage, you should go to an archival location, so you don't have to buy Rubrik clusters after Rubrik clusters. So for long-term requirements, where it is very unlikely that you ever have to restore it, but you have to keep the data for legal reasons, you would then archive it out to S3 or NFS. But the operations itself, it all is included in one single license, and that's your back-end terabyte licensing.
Understood. Next question, do you have customers who are integrating with ServiceNow?
Yes, indeed. But I am not the automation specialist. I'm more of the database guy. The implementation customer implementations that are using ServiceNow, they're available on build.rubrik.com, where you can also download a couple of use cases and documents to see how they have integrated and what kind of ticket management they are going to use with Rubrik.
Understood. And how has cloud impacted data protection today? Has it made it easier or harder, or maybe a little bit of both?
I would say a little bit of both. I mean, I'm based in Germany, and in Germany, cloud adoption is totally different from the United States, for example. Yeah, I don't know why, but the Europeans seem to be a bit more cautious. Yeah, but what you find in both continents is a hybrid environment. And hybrid environments usually require two types of backup tools, one for your on-premises data center and one backup tool for all your cloud workloads. And Rubrik is combining both workloads. So we have a global kind of management utility called GPS, and that allows you to manage all your cloud workloads and your on-premises workloads within one UI, if we talk about the backup administrators. For the DBAs, it is all native. They can use either the RESTful API or the UI, or any kind of command line tools that like ARM and natively, whatever they want to use. Then it also depends on if it's, for example, an RDS, AWS RDS setup where you can't install software on, so you have to talk to the applications directly, or whether it is a machine where you have full root access and you can install an agent onto your cloud VM and then back up like if it would be an on-premises data center VM. Yeah. So yes, it made it more complex, but it doesn't make it difficult.
Understood. I'd like to thank our speaker today, once again, Frank Schwach, Senior Solutions Architect for Oracle and SAP Solutions at Rubrik. Thank you, everyone, for joining us today, and we hope to see you again soon.
And before we wrap up, we do have one more piece of business. That's the $300 Amazon gift card prize drawing. And the winner of the $300 Amazon gift card is Greg Maynard from California. Congratulations to Greg. We'll be in touch to get you your card. And with that, on behalf of the Actual Tech Media team, I want to thank Frank for putting together a really informative presentation and for all the insights in the Q&A. I'd also like to thank Rubrik for making this event possible. And last but not least, I'd like to thank all of you for attending and for your questions. That concludes today's event. Have a great rest of your day.